Okay, so we're getting close to the end of our introductory videos relating to Algebra 2. And so we've done absolute value. Now we want to talk about inequalities. Probably if you've reached this part of an algebra course, you know how to solve some basic equations where there's an equal sign. But sometimes we have greater than and less than signs involved, and you have to solve them too. And so very briefly, how do you solve inequalities? Well, first of all, there's something called the trichotomy property. And this is the idea that for any two real numbers, either a is greater than b, a is less than b, or a is equal to b, for all real numbers. Now you might be asking, aren't all the numbers real? Hold that thought for later in Algebra 2, where we learn about imaginary numbers. Yes, believe it or not, there is a category in math called imaginary numbers. But for all real numbers, which are the ones you probably know at this point of an algebra sequence, either one number is greater than another number, less than another number, or equal to another number. Those are the only three possibilities. Now, you probably, if you're starting an Algebra 2 course, know which ones the greater than or less than symbols are. It's fairly easy to remember in that the small part of a less than points to the smaller number, and the big part of a greater than or less than points to the greater number. So when A is greater than B, the big part is pointing toward the big part, and the small part is pointing toward the small part. And it's the same way with A is less than B. The small part is pointing to the small part, and the big part to the big part. And of course, the greater than, less than symbol is basically a V on its side. Hopefully you know that by the time you've started an Algebra 2 course, which is what this video, although you might, who knows, maybe watch this for an Algebra 1 course too. Okay, so if you're adding and subtracting to something that's a greater than or less than, so let's say you're trying to solve an inequality. You've got some kind of a 2x plus 4 is greater than 3 or something like that. How do you solve it? Well, remember, when you're solving equations, you add the same thing to both sides, or you subtract the same thing on both sides, you multiply the same thing on both sides, you divide the same thing on both sides. You do that series of steps to isolate the variable, like an x, on one side, and the answer on the other. Well, how do you do that when it's an inequality as opposed to, say, an equal sign, like most equations? Well, if it's addition and subtraction, it's very easy. Easy peasy. So let's say that you have an equation where you feel like in order to solve this puppy, you're going to have to add the same thing or subtract the same thing from either side. Well, guess what? It really doesn't matter. Because if you add the same thing to both sides or subtract the same thing to both sides, the inequality remains the same. If you started with A is greater than B, then by adding C to both sides, you're still going to end up with A plus C is greater than B plus C. Or if it's less than, A is less than B. If you add the same thing to both sides, it's still going to be A plus C is less than B plus C. Same thing if you subtract. If it starts out greater than, then after you've subtracted the same thing from both sides, it's still going to be greater than. And if you start out with less than, then subtracting the same thing from both sides is going to still end up with them being less than. This makes perfect sense. But if it doesn't to you, don't worry about it. Just remember, the inequality stays the same when you're adding and subtracting. Now, multiplication and division is mostly easy with one little twist. So, if you're multiplying or dividing by a positive number, still easy peasy. If A is greater than B, then A times C is greater than B times C. And I hope you know by this part of your math career that when you draw the two letters, AC or BC, when you put them right next to each other, that means that you're multiplying them by each other. But there could also be an X, and of course a dot is also sometimes used for multiplication. Hopefully you know those things by now. But again, it's really easy. Same thing if it's less than. Then A times C is going to be less than B times C. I left the division off of this. Division is really multiplying by the inverse, 1 over whatever the number is. If you didn't understand that, just forget I said it. But basically, the same thing applies for division. If A is greater than B, then A divided by C is going to be greater than B divided by C. If A is less than B, then A divided by C is going to be less than B divided by C. So I didn't put the division in there, but it's exactly the same. If the number you're multiplying by, that is, if C is positive, then the inequalities stay the same no matter what you multiply or divide them by, that is, if you're doing it the same number on both sides. Okay, here's the trick. Here's the one little tricky bit. If you're multiplying or dividing by a negative number, the inequality switches. I'm sorry. So A is greater than B, but if C is negative, then AC is going to be less than BC. Same thing with if A is less than B and C is negative, then the sign's going to flip. AC is going to be greater than BC. See how the sign flips? It goes from greater than to less than, or from less than to greater than, if you're multiplying or dividing by a negative number. And I went ahead and put the division example in here because this is the one that matters. This is the one that's different. So if A is greater than B and you multiply it by, and you divide it by a negative number, then the sign's going to flip. A is less than B and you divide by a negative number, the sign's going to flip. Is that clear? I hope it is. Email me if you have a question. Then some miscellaneous stuff. I apologize that I hand drew this, but I didn't want to steal someone else's work. You may know how to do inequalities on a number line. So this one, if it's a solid, then it's less than or equal to, for example, here. Or if it had gone the other direction, it would have been greater than or equal to. Because the dot is filled in on the number, it's less than or equal to. And I hope you know by now that that line underneath means equal to, less than or equal to, or if it's flipped the other way, greater than or equal to. This example here, though, notice that the dot is hollow, that it's not drawn in. So this means that it's greater than 2 in this one, or if it had gone the other way, it would have been less than 2. But because the actual 2 is not drawn in, it's not greater than or equal to 2, it's everything greater than 2, not including 2. You understand? If it's a circle, then it doesn't include the 2. If this one on this side had been a circle, then it would have been x is less than -1, not including the -1, but everything negative from the -1 on. So that's something to know about drawing inequalities on a number line. Finally, there's a miscellaneous thing that's stuck into just a sidebar of a particular book I've been kind of using as a start to prepare these videos. You know, of course, math is universal, but using somewhat as a guide for topics to cover, and that's set builder notation. The way you read this parentheses with an x, a line, and x minus 5, less than 5, the way you read that is the set of all numbers x, that's the first part, such that, that's the line part, x is less than 5. So just something to tuck into your math brain for a future life. Thank you.